Hello everyone, welcome to our presentation. I am Ekin Kara, the leader of the team. I'm an information systems engineering student at the last grade. Me and my friends will show you mine and mineral applications SRS documents presentation today. For the introduction part, my friend İnanç will continue.
Hello everyone, I'm Mehmet İnanç Torun. I'm from Akademi University Software Engineering Department, and today in this project, I'll give you a general overview about our project. But before I do that, I'd like to say that today I'm very ill, so my voice may be rough, or you may hear some sniffing, coughing. So, I apologize for that in advance. So, with that, let's go back to the presentation. What is the real life problem we're dealing with that warranted this development? What are we doing? We will start with that. In today's world, everything has been industrialized. Production of food, clothes, materials, medicines, and so on. All of them have their own automated systems. Mining is also one of them. Compared to past, it's been fully automated by setting up mining sites and machines that drill through the crust of the earth and dig out rock samples containing various minerals. This is a great advancement for sure, but we still have problems within that go unsolved. One of them is the exact tallying, or rather, the identification of the dug up minerals. We can't mostly tell what is what at a first glance by looking at the rock samples. Individual labor is required here, which expends a lot of time and resources. And so comes our project, the Mineral Identification Application. It has a very straightforward objective, making a mobile application that can identify minerals from either uploading photos or taking it through the app. It will scan the image and apply a machine learning algorithm to do so. A lot of mining companies are forced to hard labor out in this field, which means that this project will be of great help to them. Individuals that desire to know what minerals they have are also benefited, as they can also use the application as well. Scope extends to iOS and Android platforms, that is a mobile app. It will either use your gallery or take a picture by the user granting camera access to the app. After the processes, you will be provided with the name and extra features on the mineral in the device's screen. As for the product functions, as I've said before, the application will have the ability to go into your gallery or use your device's camera. It will use the image processing techniques within machine learning, such as deep learning. It will also have an internal storage within the device to save the images and their data, and then external storage to store it all as a backlog. Finally, the data will be of high accuracy and contain the mineral's name and specifics. As for the manual, it's very simple. You will open the app. You will upload an image either by taking it with the camera or by selecting it through your gallery. Then the system will work and give you the results. The application assumes that you have an iOS or Android phone, as it is a mobile app, with an adequate camera resolution and you granting access to the gallery. And as the dependencies say here in summary, the system must be fast in response and the results should be of high accuracy. With all this, I've given you the general info and the cause of our project. Now I'll be handing over the next segment to my team member, Çağlayan.
Thank you so much, İnanç. Hi everyone, I am Rıza Çağlayan Demirci, Software Engineering Department, last grade. Interfaces in the computer scientific logic explain how to construct communication between programming software and hardware of the application, and them with the end user. Therefore, every application has some interfaces. As an application program interface, we have chosen React Native Mobile Application Frontend Framework, which is suitable to create create, read, update, delete projects for both Android and iOS. And Node.js Backend Framework, which are both JavaScript application construction frameworks. As you can see, we have a user here, and it is not an object in the program. It is only a scenario element. We have not any, user account, profile pages, or things like that, because our application will be used as like a detector to define minerals, and the user does not have to be the main idea of the application. On the other hand, you can see mineral is the main object of our application, and two other objects are the key points of that object. One of them is a photograph, which is taken by the user that they want to know which mineral is it, and sent by them to our application. Second is image, and the difference between image and photo is that image is an already known mineral photo, which is learned by our machine learning algorithm and exists in the application. Here you see a generic hardware interface structure for our mobile application. In the server side, on the left, a backend and a front-end program is running on the server, remote server, and the operating system runs in the right, the application by using the backend and the front-end interfaces in the mobile device. You can see the structure here. In that point, my friend Utkan will be continuing.
Thank you, Çağlayan. Hello, everyone. My name is Utkan Köktürk. I'm studying Information Systems Engineering at Akademi University. And now I will talk about our system features, like our mineral database, our access to data, how we collect and process data, and lastly, user authorization and monitoring. Our mineral data, such as names, photographs, images, and physical properties of mineral stones will be kept in a database, and our application will access and pull these data from the said database. We will use datasets from Kaggle and MineDat websites to train our machine learning model. For classification process, the application will gather its photographs from the device it is running on. To process our data, we will use image processing and TensorFlow to create machine learning model. Our application will be used by the employees of a mining company that are tasked with identifying the minerals, and the results will be displayed in detail after the classification process ends. Now, my friend Ekin will continue on.
Okay, thank you, Utkan. Now, let's continue with the function requirements, and including image processing and analysis, and we will elaborate on how the application identifies mines and minerals and how the results will be shown to the user. Start with the image processing and identification process. Image processing is one of the most important part of the project and enables the recognition and characterization of mines and minerals. This will work, analyze the image of mines by using the application. Okay, now I will continue with the basic steps of the image processing. There will be 5 steps as planned. First, the user will upload or take photo containing the mine or minerals via their mobile device. Second, uploaded photos will be automatically processed by the image processing algorithm within the app. And then the algorithm will use machine learning techniques to identify, classify, and predict the mine and minerals. The processed images will be presented in the user real-time upon completion of the process. And lastly, the types of numbers recognized of minerals will be presented to the user as a detailed report. At the moment, let's take a look to mine and mineral analysis. For the first part, we will understand data collection and preparation and analysis. Our data analysis will be done by gathering images from Kaggle and MineDat.org. The data analysis algorithm will process and collect the data and data identify to the properties of the mines and minerals from the trained data. The algorithm that determines the color, shape, and some important properties of the mines. For the second part of the mine and mineral analysis, I will show how the mine and mineral classification and showing the results will work. By using the trained data and collected information, to the algorithm correctly classify the mines and minerals based on analysis results. A detailed report will be shown to the user to identify mines and mineral types. The user can easily review and see analysis results. And in the end, the reports will be shown or downloaded in PDF or other kind of common formats so that the user can look wherever it is necessary or required. And that's it for functional requirements. My friend Esra will continue with non-functional requirements. Thank you.
Thank you, Ekin. Hello, everyone. I am Esra Yılmaz, a senior student in Department of Information System Engineering. Now, I will presenting the non-functional requirements of our project. Firstly, I would like to begin with the performance requirements. The performance of our project is the critical importance for users to access the database quickly and effectively, as well as for processing data. The response time for queries should reach a specific limit, and users should be able to access information about mineral stones easily. It should be ensured that mineral stones photos are loaded and displayed rapidly and efficiently. Database queries and operations must be completed within a specific time frame. Availability requirements is important for the mineral database to be continuously accessible, ensuring that users can always reach the information and receive uninterrupted service. Planned downtimes such as maintenance and update periods must be announced to users in advance. Emergency recovery plans and backup procedures should be established for unexpected conditions. The security of our system is of the highest importance for safeguarding data and information. Users' personal information should be securely stored and kept confidential. Data encryption methods should be employed during communication and data storage. Security vulnerabilities and weak points should be regularly scanned and addressed. The reliability of our project is critical requirement for users to have confidence in data. Daily backup of the database should be automatically and securely performed. It is necessary to prevent or minimize data loss in the event of system outages or errors. A user-friendly interface design is required. Error message and user feedback should be clear and helpful for users. It should function seamlessly on mobile device. Data input process should be designed properly, keep up to date, and measures should be in place to prevent accidental input of incorrect data. Data quality should be regularly verified. The information on minerals in the database must be current and accurate. And the project should be scalable when usage increases, particularly in case of increased number of users or data volume. The system should expand smoothly. Now we will give information about dataset selection. You have 12 minerals and mines. We have an average of 1,300 photos for each mineral. We increase some sample numbers for some minerals to identify better. What we think that is difficult to distinguish minerals manually. We believe that we can make the job of someone or mining company working in this field easier. In this case, they can make more profit and save time. I'll leave the task of explain the data summarization part to my friend Ekin.
Okay, thank you. Now let's talk about how we summarize the data. As we said before, the data will be gathered from Kaggle and mines and mineral images will gathered from mindat.org. Also, you can see the link in here. And as it mentioned before, there will be 12 different mines and mineral class, and there will be nearly 16,250 pictures and images of the mines and minerals. All right, Çağlayan, can you continue with the next topic, please?
Of course. Supervised learning is a machine learning task which is suitable to apply on the application that learns information from images. You know, our application will be construct the machine learning algorithm on many and many images. Therefore, we have chosen that way to implement our machine learning algorithm, supervised learning. Now, Utkan will be continuing.
Thank you, Çağlayan. For image processing, we will use Orange Tree to pre-process our data. After pre-processing is done, we will use Python libraries like OpenCV or Keras to finalize our training data. For machine learning model, we will mostly use CNN, which is convolutional neural networks, and we will train this model with deep learning libraries such as TensorFlow and PyTorch. Now İnanç will continue.
Thank you, Utkan. Now I'll proceed with the explanation of the title you see here, data augmentation. It is a way to artificially increase the training set by creating modified copies, like you see in the butterfly example picture in the slide here. It can make one sample into multiple samples by detexturizing, decolorizing, edge enhancing, mapping it with dots, flipping, and rotating. All these modifications let us extra samples from a single sample, which is very convenient for when our samples may not be sufficient to train our data set. As was explained previously, we have amassed a lot of samples of mineral classes from Kaggle and Mindat, but we still intend to use data augmentation as an insurance. It will be very helpful to us, like regardless if we have enough or not. With this, as a team, we have covered everything regarding our project. Thus, I conclude the end of this presentation. Thank you for listening.
Thank you, everyone.